This is AlgebraVictory Lesson 3, and we're now in topic 3.7. We're right here. So let's see what this topic is. This is called adding terms with no when clause and sometimes getting stuck. All right, now we're going to do several examples here of adding two terms together that have 5 and 3 in them. Here they are here. This is 5 plus 3, 5a plus 3, 5 plus 3a, and 5a plus 3a. And I have a table here I put together that has these same 4 problems in it. And the question we're asking is, can we add 5 plus 3 to get 8? They all have 5 plus 3 in them, don't they? Can we get 8 or not? Well, in the first one, obviously we can get 8. 5 plus 3 is clearly 8. No question about that. How about the next one? Well, this has an a, and this one does not have an a. Well, we might wonder, is 5a plus 3? Maybe that's 8a. Let's check that. So I'm putting that as an answer with a question mark here. We don't know. Let's see if it's the answer. Well, it has to work for every value of a. Let's try a value for a. Let's try this when a equals 4. Well, if a equals 4 and I plug the a into the problem, I want to see if the problem equals the answer. So here's the problem. I'm putting the a in there. This is going to be 5 times 4 plus 3, right? Equals, we want to see if that's equal. I'll put a question mark through the equal sign. 8a, well, that would be 8 times 4. Well, this is 20 plus 3 equals 32. No way. This is not valid. Can't add them. Well, what about 5 plus 3? Maybe it's just 8. Let's try that. Let's try it when a equals 7. So, putting the 7 in here, that's 5 times 7 plus 3 equals, with a question mark, just 8. There's no a there. Well, this is 35 plus 3 equals 8. No way. This fails. They both fail because this has an a and that doesn't. The answer is stuck. And when I give you a problem like this, I literally want you to write stuck down for the answer. How about this one? 5 plus the 3a. What do you think is going to happen? Do you think that's going to be 8a? Let's try this with a equals 1 and see what happens. Well, I put 1 in here. This is going to be 5 plus 3 times 1 equals, this is going to be 8 times 1. Well, this is 5 plus 3 times 1 is 3 equals 8 times 1 is 8. That works. Well, okay, it worked for a equals 1. How about if a equals 9? Well, now we're going to have 5 plus 3 times 9 equals 8 times 9. So this is 5 plus 27 equals 72. No way! This also fails. How about 5 plus 3? Maybe it's just 8. We'll try a equals 10. So now we're going to have 5 plus 3 times 10, that's a 3, times, equals just 8. This is 5 plus 30 equals 8. No way. Doesn't work. If you have 5 plus 3a, it's stuck. You cannot add the 5 plus 3 to get the a, because this one has an a in it and this one doesn't. Same here. What about this one? They both have a in them. Would that make 8a? Let's see. Let's try this when a equals 7. Okay, putting the 7 in here for a, I'm going to get 5 times 7 plus 3 times 7 equals 8 times 7. Does that work? This is 35 plus 21 equals 56. Let's see, 35 and 21. Yeah, that's 56. That works. Let's try something else. How about a equals negative 2? Well, now I'm going to have 5 times negative 2 plus 3 times negative 2 equals 8 times negative 2. Well, this is negative 10 plus this is negative 6 equals, this is negative 16. Negative 10 plus negative 6 does equal 60. It works. In fact, it will work for every value of a. No matter what value of a you plug in, it will work. The problem will equal the answer. And so, what's going on here? These two worked, and these two failed. Why? Because here, the letter groups met. The letters were the same. The two terms had the same letter. Here they had the same non-existent letter, no letter in both. Here there's the same letter in both, and here the letters don't match. And if you had some other letter like B in one and A in the other, it would also fail for the same kind of reason. It'll all get screwed up. So I have a rule here. We're going to introduce a new P rules. I'm putting in a new letter group for the rules. P stands for polynomial. I'll tell you what a polynomial is in chapter 3. Anyway, this is rule P1, which is adding terms in visible ones and getting stuck. So let's look at this rule right here. Okay, if two terms have matching letter factors, then combine the terms and add their numbers. This is what we just learned. So in this one here, cover that one up, it's 4a plus 3a. They both have a, you can add them, you get 7a, keep the same letter. Over here, 7 plus negative 2, no letter in either one, you can add them and get the 5. Okay, if two terms have unmatched letter factors, you cannot add the number factors, you are stuck. So let's look at these examples here. This one here, 4a plus 3b, problem. This has a, that has b, they don't match, you're stuck. You do not add the 4 plus the 3. How about here? 7p plus negative 2. Well, this has a p, this does not have a p. You're stuck. Do not add the 7 plus the negative 2 and get 5. No way. A couple more things. If a term has a letter but no number, then the number factor is an invisible 1. So you need to write a 1 in front of it. So let's look at 3 examples here. Let me get this to cover that up. This one here, 4a plus a. Well, the a has no number in front of it, so I need to put in the invisible 1. And now the 4 plus the 1 makes 5, so we get 5a. And this one here, p plus negative 7p. Well, the p needs a 1 in front of it. That's 1p, so I have 1 p, and I'm putting a plus before the negative, for the subtraction. So I get 1 plus negative 7 is negative 6p. And here, x plus 7y, well, wait a minute. These letters don't match. So even I could put the 1 in front of the x if I want, but I'm still stuck. I cannot add the 1 and 7 to get to 8. Lastly, if a term with no number factor has a minus sign in front of it, then write the invisible 1 after the minus sign so it becomes a negative 1. So in this one here, negative a plus 5a, so I have a negative a there. I need it, there's an invisible 1, but you put it after the negative sign like this, plus the 5a. Now I can add the negative 1 and 5 and get 4. So it's 4a because the letters match. Over here, the letters also match. They both need they both have invisible 1s. And I'm going to put a plus sign between them there. So the 1s are going to go after the 2 negative signs. I have negative 1m plus another negative 1m is a negative 2m. Okay, so that's our rule. Now I'm going to do 6 examples here. So, where's my pen? Okay. Number 1, 8x plus 9x. Well, the letters are the same. So I can add the 8 and the 9 to get 17x. That's the answer. I'll draw a line here. Number 2, I have 9x minus 5y. I could put a plus in front of the negative sign, but I'm not going to bother because I can see already the letters don't match, so I'm stuck. Number 3, 7m plus m. Well, the letters match, that's good. But what am I adding? 7 plus what? Not 7 plus 0, 7 plus 1. There's an invisible 1 there. So this is 8m. Number 4, 3n plus p. Well, there's an invisible 1 in front of the p, but it doesn't matter because the n and the p don't match. So I can't add them, so I'm stuck. Number 5, negative a minus 3a. Well, the letters do match. And I'm going to put a plus in front of this negative, so this is plus a negative 3. I also need a 1 in front of this a. So I put the invisible 1 after the negative sign. I'm going to rewrite this, negative 1a plus negative 3a. Now we can see that that's going to be negative 4a. Because I can add the negative 1 and the negative 3. And lastly, number 6, negative b plus a. Well, they both need invisible 1s. And I could put the invisible 1s in, one there, but it doesn't matter because the letters don't match, so we're stuck. Okay, all clear? All right, so now you're going to do problems 36 to 45, and I will see you in topic 3.8.